Okay, hi everyone. Let's go through the answers for the redox and stoichiometry MCQ. Okay, let's look at the first question. 2 moles of an oxidizing agent, XO4- in the presence of excess acid, oxidize this number of moles of nitrogen dioxide at room temperature and pressure to NO3-. Okay, what is the number of moles of electrons accepted by 1 mole of XO4-. Alright, so normally this type of questions, you always have to try to find out the mole ratio first. Alright, so let's see how you do it. Alright, what's the number of moles of NO2? Alright, is to the number of moles of XO4-. Okay, and I know the half equation for, I have to write the half equation for NO2 to NO3-. So NO2 becomes NO3-. So this is being oxidized. All right, so you have to calculate the oxidation state of nitrogen, because the oxidation state of nitrogen changes from +5. All right, it's not from +5, it's from +4. Okay, let me change it slightly. Okay, this NO2. Okay, so it's actually from +4, okay, to +5 over here. So it was actually oxidized. So the number of electrons have to put +E over here. Okay, so +4 to +5, it lost 1 electron. Okay, so let's calculate the number of moles of NO2 and XO4-. So this is all done at room temperature and pressure. So it'll be 96 divided by 24, right? Which actually is equals to 4, right? What's the number of moles of XO4-? So 2 moles of XO4- as mentioned over here. All right, so the very simplest ratio is 2:1. Okay, so 2:1. So with that, okay, so you can see that for every 2 moles of NO2, 2 moles of NO2 will actually lose 2 moles of electrons. So you lose 2 moles electrons, and these 2 moles electrons will be accepted by 1 mole of XO4-. So that's the answer. Where the number of moles of electrons accepted by 1 mole of XO4-, so the answer is actually 2. Okay, so that's why it's B. Okay, let's move on. Next question. The most common oxidation state of americium in aqueous solution is +3. Copper 3+ has been shown to oxidize it in dilute nitric acid, while itself is reduced to copper 2+. Okay, so again, we need to write the half equation, and then we need to also find the mole ratio. So let's see. So for reduction, okay, copper 3+ has been reduced to copper 2+. Okay, for oxidation, Am3+, okay, has been oxidized. So we don't know what's the new oxidation number, so I'm going to let it be N+. Right, so over here you can see that the number of electrons given away is actually N-3. Okay, so sometimes if you're not too sure, for example, so if you're not too sure what to write, I'm going to just give you an idea of how I actually do it. So because I know this is oxidation, there will always be an increase in oxidation number, right? So which means if say this is 5+, okay, which means if this is 5+, how many electrons will be lost is 2. So how to get 2? So 2 is like 5 minus 3. Can you see that? So normally I try to put some numbers in to guide me, to allow me to write this part here. Okay, so I mean, if you can think that way, it's quite straightforward. Firstly, oxidation, the number must increase, and note for oxidation there's always loss of electrons. So always take the bigger number minus the smaller number, which is N-3. Okay, anyway, now we have to find out the number of moles, right? The mole ratio, number of moles of Am3+ is to copper 3+. All right, so I'm just gonna do it very quickly. So 20 times 0.012 is to 24 times 0.03. Okay, so if you try to simplify this, okay, you get 1 is to 3. Can you see that? I'm actually finding the moles, volume times concentration. I'm trying to find the mole ratio. So 1 mole of this will react with 3 moles of this. So because I need 1 mole of Am3+, this one is times 1. So there'll be 1 over here. Can you see that? Yeah, so this I need 3 moles of this, I must times 3. So the whole thing will be 3. So it becomes like 3 3, and 3. Okay, so that. So when you combine these two half equations together, you must balance the electrons. Okay, so balance electrons, 3e and this one here. All right, so that's how we do it. So 3 is equals to n minus 3. All right, so n is equals to 6. So the new oxidation state of Am is actually 6 plus. And if you look at all the options, only this one gives you 6 plus. All right, only this one gives you 6 plus. Can you see that? So Am, O2, 2 plus. Oxidation state of Am is X plus 2 of minus 2. Minus 2 is for oxygen. So overall is plus 2. So you can see that X will be plus 6. Right? So that's why it's 6 plus. Okay? So the answer is C for question 2. Okay, let's look at the third question. Okay, basically all these are about the same. You need to always write two half equation and also find out the mole ratio, and then that's where you combine together by balancing the electrons. Okay, so let's look at this one. All right, so I can see from here H2S is being oxidized and HNO3 is actually being reduced. All right, so HNO3, this one is actually being reduced. Okay, it's being reduced. So I'm not sure what's oxidation number yet, so I'm just going to put N plus. So you look at oxidation number, this is actually, wait, I'm going to write this down now. This oxidation, this is reduction. Okay, maybe I write it maybe I try to write it side by side. Okay, so since it's reduction, right, since it's reduction, you need to add electrons, right? You have to add electrons. Okay, how many electrons should you add? Okay, so this is reduction, right? So the nitrogen from plus 5 become N. So the number becomes smaller, from plus 5 become N. N is actually smaller. So I'm going to here put 5 minus Ne. Okay, so this is the number of electrons that it has to accept. Okay, so the next part is we will find the ratio between mole ratio between H2S and HNO3. Alright, so over here, the number moles of H2S is 720 divided by 24000 because it's all done at room temperature and pressure, as you can see. And the number moles of this will be 40 over 1000, alright, times 0.5. Okay, so do the math, you get 0.03 is to 0.02, so 3 is to 2, right? So now we're going to balance electrons. We need 3 moles of H2S. So I need 3 moles of H2S, so I must times 3. Okay, maybe use a different color. Times 3. Okay, so I need 2 moles of HNO3. I need 2 moles of this, so I times 2. Can you see that? So the next thing I'll do is I'll try to balance the electrons. Balance electrons on both sides. So 3 times 2, 6 electrons here. 2 times this. Okay, 2 times 5 minus N. So 3 is equals to 5 minus N. So N equals to 2. Alright, so this is the final oxidation state of nitrogen. N, it must be 2 plus. So if you look at all the options, right, look at all the options, only B gives you N equals to plus 2. Okay, so N is plus 2, O is minus 2. Okay, let's look at question number 4. Potassium ferrate reacted with sodium ethanoate in an acidic medium to produce 144 cm³ of carbon dioxide. So they wrote the half equation of C2O4 2 minus. Okay, but the truth is C2O4 minus 2 minus C2O4 2 minus actually produce carbon dioxide. So I'm going to write it the other way. So C2O4 2 minus became CO2. Okay, so it was actually oxidized. So reduction. What is undergoing reduction? FeO4 2 minus to undergo reduction. Okay, so it undergoes reduction to form FeN plus. So I don't know what is this N plus. So because it's being reduced and the oxidation state for iron here is actually plus 6. Alright, so here I should write 6 minus N. Okay, 6 minus N. Okay, so it's almost like telling you Fe6 plus, just to give you an idea. How to get Fe3 plus? Alright, how you get Fe3 plus means you must take in 3 electrons. Okay, this is all about reduction, isn't it? So how you get 3? You could take 6 minus 3. Okay, 6 minus 3. So you do the same for this, right? Plus 6, 6 minus N. Okay, so I got 6 minus N over here. right? Just to give an idea how it's done. Okay, so the next thing what we need to do is to find out the number of moles, right? The mole ratio. All right, so let's look at the mole ratio. The mole ratio of C2O4 2 minus is to the number of moles of CFeO4 2 minus. Okay, but the question gave only the volume of carbon dioxide. So if we know the number of moles of carbon dioxide, we will know the number of moles of C2O4 2 minus. So number of moles of CO2 produced equals to the volume, okay, divided by 24,000. That will give you the number of moles of CO2. In this case, it's actually 0.006 moles. So since the CO2 and C2O4 are in a ratio of 1:2, you can see 1:2 or 1:2. So the number of moles of C2O4 will be half. So this will be actually 0.003. So what's the number of moles of FeO4 2 minus? You can get it from here. Okay, so it's actually 20/1000 times 0.1. So tell me what's the mole ratio. The mole ratio, if you simplify it, it will be 3:2. So having for this reaction, you need 3 moles of this and 2 moles of this. So in order to get 3 moles of this, I need to multiply by 3. In order to get 2 moles of this, I must multiply by 2. Okay, and what do I do next? We usually have to balance the electrons. Okay, so I'm just going to balance electrons. Alright, because when we put them together, we will balance electrons. So 3 times 2 is actually 6. So 2 times 6 minus n will be 2 times 6 minus n. Alright, so which means 3 is equals to 6 minus n. So n is equals to 3. Are you me? So the final oxidation state of the iron containing species, which is this, so which is actually +3. So the answer is C. Okay, for question 4 is C. Okay, let's move on to the next one. Okay, let's go through question number 5. All right. So it says sulfur is converted to SF6 by fluorine. So sulfur is converted to SF6 by fluorine. Okay, sulfur is actually converted to SCl2 by chlorine, and it's actually converted to S2Br2 by bromine. Okay, so what's the difference? You can see that the oxidation state from sulfur is changed from 0 to +6, and this one is from 0 to +2, and this is from 0 to +1. So you can see that fluorine actually managed to change oxidation state from sulfur to 0 to +6, and bromine only managed to change it from 0 to +1. So which means fluorine is the strongest oxidizing agent compared to chlorine than bromine. Okay, so that's why the answer has to be D. Okay, let's move on to the next question. Question 6. Okay, use the data booklet is relevant to this question. Using the data booklet is relevant to this question. Sodium percarbonate is an oxidizing agent in some home and laundry cleaning products. It releases so much carbon dioxide at STP on acidification. So it's really, for this part, it's actually the carbonate. It's actually when you add the acid, alright, you produce carbon dioxide and water. Okay, so that's what it means. So you can see that the carbonate and the carbon dioxide is 1:1 ratio. Okay, identical sample of titration of KMnO4. It reacts with the H2O2. So KMnO4 actually is an oxidizing agent. It oxidizes the H2O2. Right, and they tell you the mole ratio. Okay, what's the ratio of Y over X? Okay, so let's think through how we actually approach this question. So Na2CO3, alright, X dot Y H2O2. Okay, so we're gonna try to find out the ratio between this and carbon dioxide, carbonate, as well as H2O2. So let's see. So I'm putting number moles of this. Okay, is to number moles of carbon dioxide. Okay, is to number moles of H2O2. Okay, so you can see that 1 mole of this. All right, 1 mole of this. Where did I get a 1? 1 mole of this. Okay, 1. Right, the number in front. 1 mole of this will give you X. X will give you X carbonate. will also give you X CO2. So I'm going to write down here will be amount CO2 is X. Okay, one more of this will actually give you Y H2O2. Okay, Y H2O2. So how many moles of percarbonate, sodium percarbonate, I write down 10 over 1000, okay, times 0.1. Okay, is 2. Okay, how many moles of carbon dioxide? Let me see. This is from the volume, you can calculate the moles. So it's 5.4 over 22700. Okay, so what's the number moles of what is the number moles of H2O2? So I guess I can do a quick calculation here. Number moles of MnO4 minus first, all right, which is actually 24 over 1000, okay, times 0.05. Okay, so but if you want to find out the number moles of H2O2, okay, H2O2, you have to use this, right, the number moles of MnO4 minus, since the ratio is 2:5, so you can have to times 5 over 2. Okay, so this will be 24 over 1000 times 0.05 times 5 over 2. Okay, when you press the calculator, you get this is 0.001, this will be 0.002, this will be 0.003. So notice this is actually 1:2:3. Hence you can see if they ask for the ratio of y over x, okay, y over x is equals to, over here, okay, equals to 3/2. So the answer is C. Let's try question number 7. Okay, iron 2 sulfate is actually oxidized by oxidizing agent ZO3 minus. Given that Fe2 plus is oxidized to Fe3 plus, what's the final oxidation state of Z? So again, we always have to write two half equation and the mole ratio, right? So I'm going to write down oxidation. Okay, so oxidation Fe2 plus is becoming Fe3 plus, right? Plus E. Okay, for reduction, you're gonna write down ZO3 minus will become, okay, maybe I just need some space, right? Will become Zn plus. Okay, so you don't know what's the value of N, so reduction is gain of electrons. Okay, the oxidation state of Z is plus 5. Okay, and then it becomes N plus. So over here, I'm just gonna write down, okay, so it's going to be 5 minus Ne. Okay, 5 minus Ne. So this is the number of electrons that it gains. All right. Okay, so next we have to find out the mole ratio. Okay, we're going to find out the mole ratio. All right. So the number moles of Fe2 plus, right? The number moles of Fe2 plus is actually 0.002, and the number moles of ZO3 plus 0.001. So the ratio is actually 2:1. So it means that you need 2 moles of Fe2 plus. So to get 2 moles of Fe2 plus, I must multiply by 2 here, and 1 more ZO3 minus. So this one no change. So now we have to balance the electrons, right? Balance electrons. So 2 times E, so it's 2, just 2. Electrons on this side is actually 5 minus N. So you can see that N is equals to 3. Okay, so it has to be 3 plus. So 3 plus is the final oxidation state of Z. Okay, let's look at question 8. Okay, let's try question 8. An experiment, M3 plus salt reacted exactly with sodium sulfide. So sodium sulfide, you can see that sodium sulfide is being oxidized over here. I will write down oxidation. All right, so reduction must be M3 plus. Okay, reduction. So reduction again, I think is pretty similar, Mn plus. So here I'm going to write down 3 minus Ne. Okay, 3 minus Ne. Okay, so they want the final oxidation state of M. So what you need to do is to find out the mole ratio again. So you can see that the questions are all quite similar, right? SO3 2 minus is to number moles of M3 plus. So it's going to put 50 over 1000, all right, times 0.1, the number moles. This will be 25 over 1000, all right, times 0.1. Okay, so you can see the ratio is 1:2. So in order to before you can put the two half equation together, you need 2 moles of this. So because you need 2 moles of this, I will times 2 here. I need 1 more of this, so times 1, so same thing. So balance electrons, okay, balance electrons. When you put both of them, both half equation together, we have to balance electrons. So electrons on this side is 2, all right, on the other side is 2 times 3 minus n. So we can see that n is equals to, we cancel, so let me try, 2, okay, so that's answer, n equals to 2. So what's the final oxidation state M? 2 plus, right? So yeah, because n is 2. Okay, let's move on to the next question. Question 9. Okay, oxygen candle is used to provide emergency supply oxygen in spacecraft. It contains sodium chloride in a chemical mixture. Okay, where ignited, the mixture burns, and then they say thermal decomposition of sodium chloride occurs, releasing oxygen gas, forming sodium chloride as the only products. So they told you that when it decomposes, it forms sodium chloride and oxygen gas as the only products. So I'm going to write down sodium chloride and oxygen gas as the only products. So what's the ratio between oxygen and sodium chloride? Okay, you can see from here, this is 0.15, this is 0.1. So if I multiply by 2, I can see that this is the ratio. Okay, 3 is to 2. So I'm going to put down here 3 and here 2. So what is the sodium chloride? So I can see that it's going to be NaClO3, and I put a 2 in front. Again, NaClO3. So it balances, right? The sodium, the Cl, and the oxygen all balances. Alright, so what's the oxidation state of Cl over here? If you calculate, Na is plus 1. Okay, X for Cl, 3 minus 2 equals to 0. Okay, you work it out, X equals to 5. Alright, so that's why it has to be B. Okay, let's move on to the next question, question 10. Okay, the basic oxygen steel making process is a method of preparing steel from carbon-rich molten pig iron. Okay, one such impurity is phosphorus pentoxide. Okay, so calcium oxide is added to and it reacted with phosphorus pentoxide, and the product, and the only product, okay, is calcium phosphate. Okay, so very quickly, you just have to try to write the balance equation, that's all. Okay, so calcium oxide, okay, will react with P4O10. All right, then what you get is Ca3PO4 2. Can you see that? So since you have P4O10, and over here I guess there's only 2 phosphorus, right? 2 phosphorus, so I'm going to put a 2 in front here. Okay, I'm going to put a 2 in front here. Alright, so over here I'm just going to balance by putting a 6. So I just want to make sure everything balances. I balance oxygen. There's actually there's 16 O on this side. Okay, just check. 8 times 2, 4 times 2 is 8 times 2, yeah, there's 16 O also on this side. So this is actually the balance equation. So how many moles of calcium oxide reacted with 1 mole of P4O10? The answer is 6. Alright, D. Okay, let's look at question 11. Okay, how many chlorine atoms are present in so much liter of Olympic sized swimming pool? And they say the recommended concentration of level of this acid is 1.50 milligrams per liter of water. So I'm going to find out the mass first of the acid, mass of the acid. So work it out. You use 1.5 times 2.5 times 10 to the power 6. Okay, and the answer here will be in milligrams. So you can change it to, you want to change it to grams, right? So you try grams, you must times 10 to the power minus 3. Okay, this is grams. Okay. Okay, next. So I'm going to find the number of moles of the acid. Okay, so moles of acid is equals to mass that you can write down over here, divided by the MR, which is 232.5. Okay, so this will give you a value of 16.129 moles. So what next part, so what is the number moles of, what's the number moles of Cl? Okay, maybe I'll just say what's the number moles of molecules first, right? So I'll just calculate the number moles of molecules first, or number of molecules. So this number moles of acid, so the number of acid molecules, all right, equals to 16.129. I'm just going to multiply by 6.02 times 10 to the power 23. So this is the number of molecules. You can get this value. Press your calculator. So the number of what? Cl atoms, right? Okay, is this number times 3. Okay, because every molecule has 3 Cl. Okay, work it out. Okay, work it out. You should get approximately 2.91 times 10 to the power of 25. Okay, so that's answer A. Okay, work it out. Okay, let's move on to the next question. Next question. Okay, mixture of ethane and propane were exploded in excess oxygen. The volume of the residual gas was found to be 200. On being shaken with potassium hydroxide, the final volume was found to be 90. So they want you to find out what's the composition of the mixture. Okay, so firstly, what you need to do is to write the two equations. So ethane plus oxygen give you carbon dioxide and water. Alright, so first equation. Okay, so this is the balance equation for the first one. Sorry, just let me move it a bit. Okay, for the second equation will be propane. Propane is actually, use this C3 propane, right? C3H8. Okay, plus O2 to give you 3 CO2 plus 4 H2O. So 4, 6, so this should be 5. Okay, this propane gas. Alright, so this is the equation that you should be writing. Okay, so since the volume is 50, right, so I'm going to put like ICF, something like ICF, okay? Initial, change, and final. So I'm going to let the volume for this one be in xcm cube. Okay, all done in cm cube. So if that's xcm cube, this is 50 minus xcm cube. Okay, so how much carbon dioxide will be produced, right? So this one will be like minus x, this will be plus 2x, and this will be 2x. Okay, so how much, because oxygen was in excess, right? Can you see that? So this one all get used up, minus 50 minus x. The volume of carbon dioxide produced will be plus 3 times 50 minus x. Can you see? This is 350 minus x. Alright, so they say the residual gas was found to be 200. Actually, 200 refers to the oxygen, the remaining oxygen, remaining O2, as well as the carbon dioxide. Alright, but after shaking with potassium hydroxide, what does potassium hydroxide do? It absorbs all the acidic gas, which is carbon dioxide, and the final volume was found to be 90. So 90 actually refers to the oxygen, alright, because that was the left, whatever left behind. So it tells you that the carbon dioxide that was produced in this reaction is actually 200 minus 90, which is actually 110 cm cube. So if you work it out, okay, this part is the volume of carbon dioxide from here, and this is the volume of carbon dioxide that is produced from propane. You add them up together, so 2x plus 3, 50 minus x will give you 110. So work it out, 2x plus 150 minus 3x equals to 110. So I can see that by doing the math, x equals to 40. So x is 40, so here is 40. Okay, so the volume of ethene should be 40, and the volume of propane should be 10. Okay, so that's why the answer is D. Okay, let's move on to the next question. Okay, so when the airbag is activated, right, sodium azide, right, first decomposes to give sodium and nitrogen. and then the sodium that was formed will continue to react with potassium nitrate to produce even more nitrogen. Okay, so the nitrogen produced in these two reactions is actually needed to inflate the bag is 2 moles of gas, which is here and here must give you 2 moles, right? So let's see how we go about doing this. Okay, so what's the amount of sodium azide needed to inflate the bag? So let's let X be the number moles of sodium azide. So the number moles of nitrogen produced here will be 3 over 2x moles, right? Let X moles be the, so that's 3 over 2 X. So the number moles of sodium here will be X, all right? And this sodium here goes here, all right? So you have X moles of sodium, so you end up having 1 over 10x, right, moles of nitrogen over here. So let's add these two together, right? So here and here, add them up together. Can you see that? Okay, so because of the ratio, why is it 1 over 10? Because here 10 is to 1. I hope you can tell. So 3 over 2x plus 1 over 10x must be equals to 2, right? That's the 2 moles of nitrogen. So do the math, right? I think you can see it's 30x plus 2x over 20 equals to 2, right? So 32x equals to 40. So x equals to 40 divided by 32. So pass your calculator, you definitely get 1.25, okay, moles, right? So the amount of sodium azide is actually 1.25, so the answer is C. Okay, let's try the next question, question 14. How many neutrons are present in 0.13 grams of this carbon isotope? So the number moles of this carbon isotope will be 0.13 divided by the mass number, which is 13. This gives you 0.01. All right. So how many neutrons, right? So how many number of atoms, okay, is equals 0.01 times Avogadro's constant, which means you times L. So each carbon, right, carbon actually you can see is 13.6. So each carbon atom actually has 7 neutrons, right? 13 minus 6 equals to 7. So each carbon atom has 7 neutrons. So if there are so many carbon atoms, the number of neutrons, right, the number of neutrons will be equals to 0.01 L times 7. So it's going to be 0.07 L. Okay, so the answer is B. Let's try question 15. Zinc attenuate may be taken as a dietary supplement. What's the total number of ions present in 5 cm³ of zinc attenuate? Given this is the concentration, so we can actually find the mass first. Okay, the mass of zinc attenuate. Okay, just let me write this down. Okay, the mass of this, okay, which is actually 10.64 times 5 over 1000, and this will give you the grams, right? You can get it. So the what's the moles or the amount, the moles of this? Okay, you just divide by the MR. Okay, so work it out. Okay, you're gonna 10.64 times 5 over 1000, okay, divide by the MR, which is 183.4. Okay, I think the answer for this should be 0.00029. So the number of units, right, equals to 0.00029 times 6 times 10 to the power 23, and so the number of ions, right, ions is equal, so each of them here, there are actually 3 ions. Notice there's actually 3 ions because there's one zinc 2 plus and there's 2 CH3 COO minus, so the 3 ions. So number of ions will be 0.00029 times 6 times 10 to the power 23. Then after that, you still must multiply by 3. Okay, so this will give you an answer of 5.22 times 10 to the power 20. Okay, that's why I got the answer is B. Okay, let's move on to the next one. Okay, let's look at question 16. When a sports medal with a total surface area of 150 was evenly coated with silver by electrolysis, this mass increased by so much. How many atoms of silver were deposited per cm cube? So actually, you can find out the number moles of silver, which is 0.216, okay, divided by 107.9. This gives you a value about 0.002 moles. Okay, so that. So the next part, you can actually calculate the number of atoms so the number of silver atoms per cm cube. I'm going to just do all together. So 0.002 is the number of moles of silver. You multiply by Avogadro's constant, 6.02 times 10 to the power 23. This will give you the number of atoms. Alright, and then per cm cube you divide by 150. Okay, you get a value of 8.03 times 10 to the power of 18. Okay, so this will give you answer of A. Okay, let's look at the next one. Which of the following contains the smaller number of stated atoms? So for A, alright, we do A, B, C, and D. Yeah? For A, the number, we can find out the number of moles of NO2. So number moles of NO2 is 48 divided by 24, or RTP. Yeah? So there's number moles of NO2, but the number atoms you still have to, smaller number of stated atoms, the oxygen atoms, so you must multiply by 2. Okay, the number of oxygen atoms you multiply by 2 because there are 2 oxygen in one molecule, so this gives you a value of 4. For B, the number of SO2, number moles of SO2 is this, but oxygen you still must multiply by, but not oxygen, sulfur, so you multiply by 1, so this value is 2. Let's look at C. 44 divided by 44. 44 is the MR of carbon dioxide, but every molecule, right? Every molecule only has one carbon. They want carbon, so I multiply by 1. So this gives you a value of 1. D. Okay, the N2O, the MR is also 44. So this is the number moles of N2O. They want nitrogen atoms, so you must multiply by 2. So this gives you a value of 2. So the answer has to be C, the smallest number of stated atoms. Okay, 1. This answer is C. Okay, let's look at question 18. Gases given off during volcanic eruptions include H2S and CS2. So I'm going to write the both equations here. Okay, just write it here. H2S, okay, plus oxygen will give you SO2 plus H2O. Okay, plus H2O. I guess if you need to balance this, 3 over 2. Okay, the other one, CS2 plus oxygen will also give you carbon dioxide plus SO2. Alright, SO2, these two are the gases. So to balance, I put a 2 here. Alright, so I put a 3 here. Okay, it's all balanced already. Okay, so 40 cm cube of this sample and the ratio is 3:1, which means there's actually 30 cm cube of this and 10 cm cube of CS2. So in fact, I'm going to write down ICF, but all these are in terms of the volume. So this will be 30, let me see here, 30, and this is 10, alright? So I'm just going to find out, they say it was analyzed by using 100 cm cube oxygen. In fact, H2S, right? H2S, if it reacts, it only requires 45 cm cube of oxygen, and for CS2, when it reacts, it only requires 30 cm cube of oxygen. Alright, so why I say that? Because the ratio is 1:3 and the ratio is 1:1.5. Can you see that? Okay, so actually by right, only how much oxygen will be used up? There will only be, let's check, there are only 75 cm cube of oxygen used. Alright, which means there will be 25 cm cube of oxygen remaining. Alright, remaining because you used up, you started 100, so there'll be 25 cm cube remaining. Okay, so let's see how much sulfur dioxide is being produced. So you can see from here, 1:1, right? So this is like minus 30, this will be plus 30, and this is 30. Okay, so I put 30 over here. First I circle. Okay, 0, 0. So if I put minus 10, minus 30, right? This is plus 10. I'm just using the mole ratio. I hope you can see 1 is to 3 is to 1 is to 2. So the change always follows the mole ratio. Minus 10, minus 30, plus 10. And this one plus 20. Okay, so very quickly I'm just going to circle. Okay, all the acidic gases. So the volume of gas remaining was treated with excess sodium hydroxide, and the volume of gas measured again. Okay, given that, so what's the volume of gas mixture after burning? After burning, there'll be 25 cm³ of oxygen remaining. But how much are the other acidic gases that's present? SO2, CO2, and this SO2 over here. So you notice there's actually 60 cm³ of CO2 and SO2 all together, right? So the amount of gases remaining should be 85. So I'm going to put out 85 over here. So volume of gas after adding sodium hydroxide. Sodium hydroxide is a base. It will absorb all the acidic gases, so leaving only the oxygen behind. So the volume of gas mixture after adding sodium hydroxide has to be 25. Okay, so the answer is C for this. Okay, let's look at the next question. Okay, okay, this one, the NXOY reacts hydrogen to give you ammonia and water. So the water collected, so you know there's 0.133 grams of water. Okay, so you know that ammonia and HCl will react in a ratio of 1 to 1, isn't it? Okay, so I'm going to write down very quickly. So this is what you get, right? They react in a ratio 1 to 1. So if you know the number moles of HCl, you know the number moles of ammonia. All right. Okay, so I'm going to write down the mole ratio between these two, right, which is actually X and Y. So the ammonia is actually the same as the amount of HCl used, 18.5 over 1000 times 0.2. Y is the water, right? So 0.133 divided by 18, which is the ml of water. Press your calculator. Okay, you'll realize that the ratio will be 1 is to 2. Okay, the ratio is 1 is to 2. Okay, so X is 1 and Y is 2. So you start back here. It should be, okay, it should be NO2. Okay, NO2. But at the same time, what could be the oxide? As long as the ratio is 1 is to 2. So this is a bit tricky. It could actually also be N2O4. Okay, it should also be, because as long as the N and O, the ratio is 1 to 2. So both are actually feasible. So if you get, like, say for example, if you have N2O4, right? Yeah, N2O4, you end up getting 2 ammonia and 4 water. Okay, with hydrogen of course involved here. Okay, so yeah, it's definitely possible. Okay, so the ratio here is still 1 is to 2. You see that the ratio is still 1 is to 2. Okay, so the answer will be 2 and 4. Okay, D. Okay, D. Okay, let's look at question 20. Okay, let's look at question 20. Methane was burned in an incorrectly adjusted burner, and then you get carbon monoxide and carbon dioxide. So methane, right, I'm going to write two equations. First one is to give you carbon dioxide, and the second one is to give you carbon monoxide. Right, so if I try to balance it nicely, this will be 2, this will be 2. Okay, if I try to put 2 here, but this will be 1.5. Okay, this will be 1.5. So if they mentioned that the carbon dioxide and carbon monoxide in the ratio is 95 is to 5, and the amount of methane used is xdm cubed. What would be the volume of oxygen consumed? So I'm pretty sure that this one should be 0.95x, okay, dm cubed, and this will be 0.05x. Okay, so the why I do that, because methane and carbon dioxide is 1 to 1, methane and carbon dioxide 1 to 1. So if I work backwards, I can see that actually originally I used 0.95x, dm cube of methane over here. Okay, see 1 to 1, and here since it's also 1 to 1, right? So the amount of methane here is also 0.05 x dm cube. Okay, add them together. This must be so this is actually going to be x dm cube, isn't it? Okay, this will be x dm cube. That's how I could see it, right? So let's check. Okay, so the amount of oxygen, all right, the amount of oxygen used here, it may be double of this. Okay, so it's going to be 2 times of 0.95 x, all right, and then over here plus 3 over 2 times 0.05 x. All right, so this is the volume of oxygen. Okay, volume of oxygen. So let's try to get the way the answer wants, right? So I'm going to change this one here to x minus 0.05. okay, x plus 3 over 2 0.05 x. So this will give you 2x, okay, minus 0.05x plus 1.5 0.05x. So you press off, if you look at it carefully, this will give you 2x. So minus 2 plus half, 1.5 is left minus half, right? Minus half 0.05x. You see that? So based on what I just showed you, in fact this one is option C. Okay, so that's how we do it. Alright, so that you need a bit of manipulation at the end.
Thank you for watching the Twig Learning Center chemistry tutorial. I hope you learned something new. Don't forget to click the subscribe button so you'll be updated when new videos are posted.